Well, good afternoon. So, did anybody take any medication today? Maybe a vitamin? Maybe some hangover medication? Maybe you have a prescription. Maybe you injured your ankle running and you have anti-inflammatories. Maybe it's cholesterol medication or blood pressure medication. Do you ever stop and wonder where all these medications come from? I don't mean the pharmacy. I mean, where did it come from to go to the pharmacy? It came from some very important pharmaceutical companies, some big ones, such as Merck. And George Merck said that medicine is for the people, and that if you remember that, then the profits will follow. So you think about all the medications that we have out there. It's incredibly expensive to produce them. There's a lot of research and development that goes into it. There's a lot that goes into designing the manufacturing processes. And that results in a pretty expensive product for some very high-end pharmaceuticals. So what if we could cut the R&D cycles in half? What if we could make our manufacturing processes more efficient? What if we could tighten up our supply chains? Well, then we could produce products that cost a whole lot less, and we could get them in the hands of the people that need them the most. So that's what we're doing. Booz Allen's partnered with Merck, and we're using Amazon Web Services, and we're doing a whole bunch of those things to help lower the cost of the whole drug production pipeline and delivery so that people around the world can get the medications that they need. So all those things, shortening the R&D cycle, coming up with better manufacturing processes, optimizing your supply chain, it all relies on data. And that's why data science matters, because data science has the opportunity to completely revolutionize the world's healthcare. And a piece of that is pharmaceuticals. So here's a case in point, medicines for the people. There's something called the rotavirus, and that creates flu-like symptoms, and it attacks mostly children. It happens to affect people in poor parts of the world. So you see those little red dots up there? Each one of those represents 1,000 deaths due to the rotavirus. And you see the blue dots? Those are the people that can buy the medication and afford the medication. So clearly there's a mismatch between the people that can buy it and the people that are getting hit hardest by this. And that's just one example. There's plenty of other pharmacy products, pharmaceutical products, that the poorer people of the world actually, they really need to get their hands on. So the goal with data science and pharmaceuticals is to take all those little red dots and wipe them right off the face of the map. We can start doing that through data science. So how do we do that? To come up with good analytics, good data science, it requires a really deep understanding of the business knowledge, the context in which we're trying to solve problems. It also requires deep skills in mathematics, statistics, machine learning. And frequently, this involves really large data sets. So it requires good software engineering and the ability to know how to scale out analysis and data platforms. So that's a tall order for an individual to fill. Anybody in here can do all three of those things? We're hiring. So what we do is we build teams that encompass all these three skill areas. And so we'll bring together the people with the expert business knowledge and the mathematics and the computer science and build these teams, these data science teams that can go out and solve these really hard problems. And the approaches we take are slightly different than some of the traditional approaches. So one of the important differentiators is moving away from just strictly parametric models. So with a parametric model, we generally make assumptions about the processes that are going on. And then we fit data to the models to estimate the parameters. Those work well in some cases. In other cases, they don't. When you have a lot of data, you can let the data tell the story. You can find patterns in the data, let the data tell you what's in it, versus us making assumptions about what might be in the data. So that leads to the ability to do data experiments to inform discovery. And also, through data science approaches, they're very fast and agile, so it's okay to fail. And in fact, we learn a lot from failures. In this analytics project that I'll talk about with manufacturing and improving yield and understanding yield, we made a lot of mistakes along the way, but we made them quickly. We learned and we moved on. Also, we can ask bigger questions now. So instead of focusing on one narrow slice of the problem, we can look at bigger slices. So with big data and large data sets, you need a way to store and process all that information. And so the data lake concept comes into play here. Now the analytics that I'm going to talk about in a minute, they sit at the top of the stack. And later we'll talk about what lies at the bottom of the stack. Nick will talk about that, what helps support it. The analytics work that we did really didn't require identity management or heavy security, but when you deploy big data solutions for a whole enterprise with very sensitive data, that's when you really need to think through all your security. So Nick will give some good design patterns that help inform how to enforce some of those security policies. So in a real quick summary, at the bottom we have your infrastructure pieces like EC2. On top of that, we create some sort of data lake, usually based off of Hadoop and HDFS, but it could be something else. Further up the stack is where we run our analytics, and at the very top is where we expose those insights that help people drive actions. So now let's talk about a real data science example. So recall back to that map I showed with all those red dots in the poor parts of the world and all the blue dots where people could buy the medication. Merck has another product that they sell very large amounts of worldwide. It's a very important medication that keeps people from getting an illness that kills us. It so happens that that particular product has high incidence rates in the poor and developing parts of the world. And it also happens that that product is fairly expensive just because of the long R&D cycle that was involved and the complex manufacturing process. Do you guys know how much it takes on average to bring a pharmaceutical, like a prescription pharmaceutical product to market? It's a lot. On average, it's over $2 billion. And so pharmaceutical companies have a lot of products in their pipeline, and not all those products actually make it to market. So it's very costly. It's very costly to make these products. So what Merck was really interested in is now that they have this product to market, is there a way that they could improve or at least understand the drivers to variation in product yield? And so that maybe they can control that variation and lower the cost of manufacturing and lower the cost of the product and get it in the hands of the people that need it? So that's the problem that we struck out upon. And this is a challenging problem because there's thousands of sensors that record time series such as pressure, temperature, pH, auger speed, drip rates of nutrients. Very complex. It's a complex manufacturing process, multiple stages of production. It takes a long time. It's not like an hour or a day. This takes several days to weeks to produce a single batch of the product. And there's a lot of data, too. So we weren't the first ones to take a look at that problem and try and understand the yield. Their engineers took a look, too. But just because of the fractured nature of the data, some of the data is in this source system, other data is here, other data is here, other data is here. It's really hard for the engineers to get all that data together and analyze. Also, it's very complex. So what they did was ended up analyzing only a single piece of equipment throughout the whole production process, or only looking at a subset of the batches that have gone through the process. And so that was kind of a narrow focus just because of the nature of the data and the problem. It's a very large problem. So we came on in and partnered with Merck. And we thought differently about it. We thought bigger, and we wanted to let the data tell the story. So we put the data in a data lake platform. And what that did was brought all the data together from the fragmented systems. We could align the data to batches and begin analysis around batches. We had this hypothesis that if a batch had a similar run through the entire production process as another batch, then those batches probably had similar yields. So it kind of intuitively makes sense, right? So the idea was that we could find patterns that were associated with low yield and patterns that were associated with high yield and get an understanding of what's driving this product variation. So the result was we were able to build a model that accounted for over 50% of product variation. And stop and think about that for a minute. We know what's driving more than 50% of the variation in this product. So that's a big deal. And industry recognized that. In fact, this particular analytics project, data science work, won the Information Week Business Innovation Award. So that's a big deal. Now, back to the story, so we can get a little geeky here. So we had this assumption, this hypothesis, that similar production runs through the process would result in similar yield characteristics. So what we needed to do is compare a bunch of time series together. And so we implemented something called dynamic time warping. And dynamic time warping is really nice because it can give us a measure of similarity between two time series. And those time series don't necessarily need to be on the same time scale. Since we're dealing with a biological manufacturing process, one piece of the process could finish in 5 hours, and then a different batch could run through that process, and it may take 7 hours. So dynamic time warping could account for the different time scales. So what we ended up doing is implementing this through a MapReduce paradigm, which is actually really important, because even if a single machine were able to do all these computations, the computational runtime would have been well over a year, between 1.5 years to 2 years. And because of the scale-up, scale-down nature of Hadoop and Amazon Web Services, we're able to spin up the cluster compute capacity and finish the computations in about a day. And then when we were done, we scaled it back down. So it saves a year off compute time, saves a bunch of money for Merck. So we end up with all these similarity measures. And what do? We sort the batches according to yield from the lowest in the top left to the highest yield in the bottom right. And we do batch-to-batch similarity comparisons. And so if time series look very similar for high-yield batches, we'll see a bunch of red in the bottom right corner for that particular metric, whether that's pH or auger speed or drip rates of certain nutrients. And if we see a big red dot in the top left corner, that means that there were similar patterns associated with low yield. So what we're able to do then is go back and look at the individual time series that are showing these clustering patterns. And we can see that there are certain properties with the time series, such as maybe the area under the curve and certain parts of the time series or the slopes of the time series, and use those as inputs into regression models, which then accounted for 50% of the product variation. So when you think about the scope of this problem, this particular product, they're selling billions of dollars of it per year. And to be able to understand the drivers of the yield, that translates to millions of dollars of savings annually, which Merck shares some of that, but then is also able to pass along to the consumers. So through this analysis, it's helping Merck get people medicine that they need at a lower price that they can actually afford. So that's one piece of work that we've done in the pharmaceutical industry. For several other of our clients, we've done a bunch of other types of projects involving large data, the data lake. So that the use cases span R&D, manufacturing, supply chain, marketing, business operations. So we'll do things like recommendation engines. I'm sure people in here have used Amazon and bought a book or two, or electronics or something else, and you get recommended new products. Imagine how that affects people in the R&D space, or looking at supply chain information around possible procurements or RFPs or tenders. So the data lake stores all the data and then serves up different views on the data according to people's needs and use cases. And in some cases, that's very sensitive data that only a subset of the enterprise should have access to. And that's where a lot of the security controls come into place. So Nick's going to talk a little bit about that now.
All right. Thank you very much. Thanks, Brian. So when we're talking about Amazon, we're going to go a little bit down in the tool chain here. We're going to let you understand about CISOs and CTOs and what they're interested in about when we want to move data to the cloud, how do we protect the data in the cloud when it's sitting there. So here's an example of a particular implementation that we have. Is bottom on the left, particularly picking up relational database service, Oracle and the RDS servers that they have in Amazon, encrypted S3 on the bottom tier, A lot of MapReduce going on, or installed Hadoop on EC2 on both the sides. We do use some large-scale petabyte databases, just like Redshift, but there is other tool sets as well. And of course, Hadoop sitting right on top of there. It enables you to have a very, very quick response, but very, very quick scaling abilities. What I'm really going to talk you to is I'm going to show you 3 reference architectures that we have. We look at the problem of securing data in the cloud as 2 measures. A preventative measure, where we prevent it from occurring in the first place. And then Amazon does a phenomenal job of providing services for that, but we add on top of it. So there's a bunch of tools I'm going to be sharing with you about how we add and complement those services. And then we look at it from a detective perspective. So we're constantly using the very similar analytics in the data lake to actually predict and analyze and detect what's actually occurring in the environment. We're scraping logs, we're looking at threats, we're looking at things that are happening, and then we alert on them, and we respond on them, and we accelerate. Just so you know, all these are going to be published on our Git site, so please take your shots, but we'll be publishing them, and they'll be on SlideShare as well. But there's a lot going on these slides, so let's kind of start on the bottom left-hand side over here. So you've got a privileged user, you've got a data scientist, you've got a mathematician, you've got an operations staff, and you've got an administrator. The recommendation, the best practices that Booz Allen implements is that those people actually have 0 access to the Amazon environment. We actually use a security gateway, a privileged identity management solution. The privileged identity management solution, PIM for short, actually goes and gets the credentials. It will go to Amazon IAM and actually create them on the fly. So no IAM account management done by us, it's all done by the PIM tool. So it's a security gateway that you're accessing. The developer authenticates, or the analytics person authenticates with the PIM tool. They'll display a list of the services and the servers that they can go administer and they can go play with. The credentials are created and they're time-bound. So typically, if it's a day job like we were doing at Merck, the credentials expire at 24 hours automatically, and the environment completely collapses and those credentials are gone forever. So it's very, very consistent. It helps you protect from both an insider threat about people getting access to data, and it allows you to protect the cloud service provider insider. So a lot of CISOs are interested about, now I'm moving my data to a cloud provider, how do I guarantee that they have the controls in place to stop what's going on? So you have policy managers, you have audit and logging going on, but the key is it's 0 trust. No one is giving anything, just like they do with security groups, where it's 0 privilege. We trade a whole 0 trust experience. No direct access to the console either. You actually use a secure gateway to get to the Amazon console if you have to administer some stuff. But again, those credentials are created, and then they collapse down as soon as you close the console down. But what gets even better is when a privileged identity user types a privileged command. There's a whole other piece that kicks in, where we actually start to record and screen scrape and actually are watching what's actually going on and storing that information in S3. So they type in a sudo command, they type in a yum update, or they type up some other really, really kind of crazy commands. We start recording that information and can watch that and play it back at a later time. So we're watching all the keystrokes that are going on right then and there. All right? And then we also, the key benefit of this particular solution is Amazon makes it really easy to SSH and RDP between boxes. So this entire solution prevents that. There's no leapfrog hopping between servers, which is very, very simple to do, and typically very, very hard to detect and stop. PIM tools really, really help that. Also, Amazon allows Gemalto, multi-factor. We've taken that and expanded on it. We do a lot of government work, PIV cards, CAC cards, where the military and they're logging with smart cards. We've expanded this particular solution, and they can single sign-on directly from their cards. And then we also, RDP session. You can actually video record the RDP sessions that are going on right there, and you can trace back every single command and every single thing that was done, all stored in S3. So with this, key takeaway, 0 access to the console, 0 direct access to any of the machines. All data lake access is through the gateway, and everything is logged. So you can log it, you can use Securonics, you can use Apache Knox. There's a bunch of tools that are out there to enable you to do it. Very simple, but very, very compliant. As I mentioned, you can multi-factor authentication, very important. So once I've got this information, and I've got these servers running, and I've got this data out there, and I've managed to stop the administrators from getting access and the data scientists can't travel around, what detective things are we doing? So we're scraping the logs, Windows Event Viewer, router logs, CloudTrail logs, and we put them and we run them back into our own data lake. So we're drinking our own champagne to actually detect what's actually going on. You typically, when you implement this kind of solution, you baseline it for normal behaviors. You typically train it. You train the analysis, get to a common thread of what the allowable commands are. And then, of course, what the unallowable commands are and the things that we're trying to watch for. We monitor and we identify, we analyze it, we work out what the risk factor is of it, and then we alert on it. So text messaging, simple notification service, get that sent out to you. The identity analytics really does help you govern the entire analytic rights and policies that you're out there. We use this often in many, many enterprise clients, and it's very robust, and it scales immensely well. The hardware is it's a hardened virtual appliance that's sitting up there on the left-hand side, and both hardware and software, and it allows direct RDP, so they don't allow direct RDP and SSH access. So it's a hardened appliance that you're actually implementing. And then the identity analytics we have, they have access to every single log we have going on. And with some announcements I hope they're coming out this week for CloudTrail, we'll get even more access to the information. So key takeaways on this one. Based on the normal expected behaviors, you monitor and you alert, and obviously a risk, and you have a threshold of what's going on. Govern the rights, and it's hardened virtual appliances, so no one can attack that threat vector. There's nothing going on. No one can get access to that particular machine. And if they do get onto that particular machine, there's not like 22 is blocked and all those kind of protocols, but if they get on there, they get a menu panel. There's no command line access whatsoever, completely hardened. And then we access and we scrape every single one of the logs, and we store them in S3. So the common thing I have was when I talk to my clients is that they're like, well, we don't encrypt anything on premise today. What solution do you have to actually help us kind of encrypt? ABS has done something, but Amazon's released it, but they keep the keys. We really want to keep the keys. We want to own that piece, and we want to be able to have the ability to rotate the keys. So we have this whole cryptography solution. SafeNet, if you guys do a tour, the Partner Expo, Secure Onyx is there, Exedium from a privileged identity management, and SafeNet all have typical products we typically use, and there's a number, it's a whole very big emerging market. But here we're storing and we're encrypting the EBS volumes, and we're encrypting data on top of the encrypted, inside the virtual machine itself. In this particular analysis, an administrator gets onto the machine, they can see the data, they can see the file, they can see the metadata, but they can't open it. The only thing that can open it was the application that created it. So the reference architecture, the data lake, it created the data, it can see it, it's all encrypted. But the administrator just sees a 50 meg file sitting there and has no access to it whatsoever. And this is a natural evolution. Now these are actually hard appliances. These are physical appliances that you're putting on premise and you're putting out into the cloud. We recommend you encrypt absolutely everything you put in the cloud. With my clients, they have like zero tolerance for risk and for anything being exposed that's out there. The keys are held in a cloud hardware security module, Cloud HSM. So they keep their key kept there. And if someone leaves who changes their role, or they actually leave your organization, you can rotate the entire key set right on the fly and throw the previous keys away. Completely useless. The challenges, I would say, Windows 2003. Can't wait for that thing to be over, I have to tell you, next July. But so some of the appliances are much more 2008, 2012, and the latest RHEL releases. And optionally, you can actually use, Amazon has a very, very toned down version of SafeNet, Cloud HSM. Very good product, highly recommend it. But for the enterprises that we deal with, and particularly the size of Merck, and they have a physical appliance that sits inside their data center. Key takeaways on this particular one. So encryption is not a silver bullet, all right? But you should look at the security controls that are relevant to your environment. We call it the risk register. We have a risk register of everything the cloud service provider administrator can do, and we do it likewise for the data scientist, the mathematician, the administrator, and the ops guy. We risk, rate, and rank what they can particularly do on the environment. And then we enforce key management best practices against each one of their particular threats and what they can actually do. And then optionally, you can use the cloud HSM.
Well, thank you, everyone. I hope that you're able to walk away with two thoughts. And one is that data science really can change the world. It can help us get medication in the hands of people that really need it by cutting the costs of the medication. And also that as we develop these enterprise-wide analytics on a data lake through Amazon, that there's some great ways that you can secure all the data all the way down to the disk level. If anybody's interested in talking with us either about security or about data science or the manufacturing analytics or our broader data science practice, we have a booth right to the right of the developers lounge in the convention area. So come on by. If you're really interested in learning some of the data science techniques that we've applied here and elsewhere, we have an online training platform called exploredatascience.com. Check it out. I also can give you a little card with free access to it. And we're running a competition. If anybody wants to win a 3D printer, all you have to do is score more than 1,500 points right now, because that's what the leader has on the leaderboard. So get one of those cards from us and score more than 1,500 points. You may be able to walk away with a 3D printer. And lastly, the slides will be up on our GitHub account. We also have a couple other open source products that we have, so go check that out. And I'd like to use the rest of the time for questions if anybody has questions for us.
Right in the front.
Yes, sir. From high to low? I can't really tell you the specifics because it's very proprietary. But it was a lot more than their typical product was, and that being able to control that by 50% is highly material to them. Yes, sir.
Are you also working on the discovery side of drug development in addition to production?
Yeah. So we have some clients who are doing work in that area. And actually, if you'd like to talk more about that, stop by the booth because we have some folks that are working on those types of projects that I can link you up with.
All right. Also, any other questions on anything Amazon? We do lots of different implementations. Correct. So one of the tricks we use is actually we pass the decrypt key on the launch of the particular instance. And then it goes to has an S3 file. It will pull down. It's been encrypted with the same key, and it decrypts it on the fly. And it tells it where the credentials are to get everything else in the system. Typically, I have a maintenance server that kind of does that kind of thing, and then it hands it out to the other machines. But it allows us to rotate that key very, very quickly. But it's typically a user credential that's handed and passed in there. And you can do it as a file as well. You can do it as an on launch, a file which pulls it down. Sure. Yeah. You download a different layer. And so Chef helps with those kind of specifics as well. So a lot of the tools we use with Chef, we can actually do that virtually in memory. Yeah. And you connect it to an LDAP, or you connect it to another HSM where the key is stored. Yeah, like CyberArk, and Exedium, those kind of products is where it's actually the key is held. But both of those will be on premise. Within the instance, that particular product was one called Vormetric. It's an analytics product, came out of the intelligence community. But yeah, it sits there. It has a separate policy manager where you write down what kind of the tricks you're looking for, the applications you're looking for that are creating data. So like the Oracle and the Oracle SID is creating the data. But yeah, you encrypt it on the it will do volumes, it will do directories. We love doing it around just particular data volumes itself, not the log file, not the the syslogs and everything else that's going on in those databases, just the data file itself. But it scales really, really well. For 50 terabyte kind of volumes, when we stripe them together, you can make it really, really big from an encryption. No performance whatsoever. Very impressive product. Yeah. All right.
All right, thank you.
Very much.